So far, we have seen the qualitative analysis for interaction, and qualitatively analyzed and find what are the out of 24 combinations for flash drum, we selected the only one combination by qualitative analysis. That can be found by quantitative analysis. For that, we can use relative gain array, RGA, relative gain array. Relative gain array means it gives a measure for interaction. Relative, suppose if it is a 2x2 process, means the relative gain array consists of 4 variables, 4 constants. They are lambda 11, lambda 12, lambda 21, and lambda 22. What is the definition? What is the definition for lambda 11? Lambda 11 is a ratio of change in y1 with respect to change in m1 while keeping m2 constant upon change in y1 with respect to change in m1 by keeping y2 constant. How to find this? The numerator can be found by in open loop. For example, you want what is the numerator? Change in y1 for change in m1, keeping m2 constant. It means how to keep m2 constant in open loop. This is also in open loop. Both are open loop. If you do the experiment, you will get delta y1. Delta 11. Lambda 11 you will get. You will get lambda 11 you will get. How to get denominator? Denominator is change in m1. What is the change in y1? If you find, you will get denominator, but keeping y2 constant. Because it has interaction. That's why any change in m1 will affect y2. So how to keep y2 constant? We have to close the loop. So the second loop will be in closed loop to find the denominator. So the first loop will be open loop. Second loop will be closed loop. If you do that experiment, then you will get the denominator. So this is open loop, both open loop experiment. This is other loop is closed loop. If you do like that, you will get lambda 11. In the same way, we can find all the other 3. Let us see one example. Suppose you want to find lambda 12. Lambda 12 means what? Numerator is what? Lambda 12 means lambda 12 I want. How to find that? Change in m2, delta m2. For that, what is the change in y1? We have to find. That is numerator, keeping m1 equal to 0. You can easily get the numerator, no problem. How to find the denominator? You have to change in m2, change in y1. For change in m2, we have to find. But you have to keep y2 constant. To keep y2 constant, you have to close this way. You have to put a set point for this y2. Set point for y2. You have to close and you have to manipulate m1. You have to manipulate m1 to control y2. That's all. If you do like that, you will get lambda 12. In that way, you can find all the 4 elements of this. What are the possible combinations for this? Suppose the RGA, the elements of RGA are lambda 11 is 1 and the lambda 12 is 0. Lambda 21 is 0. Lambda 11 is 1. It indicates that there is no interaction because lambda 12 is 0. This corresponds to m1. This corresponds to y1. Therefore, y1 can be controlled by m1. There is no interaction at all. In the similar way, this column corresponds to m2. This row corresponds to y2. There is 0. There is no interaction by m1 with y2. Therefore, m2 can be used to control y2. No problem. From RGA, we can understand that there is no interaction. Suppose we are getting the other way. What is that? In that case, you are getting this 0. This is 1. This is 1. This is 0 means m1 has no effect on y1. That's why m2 and m2 can be used to control y1. there is no interaction because it is 0. Similarly, M1 can be used to control Y2. There is no interaction. That is the meaning of this 0 indicates. Suppose I am having another relative gain array. In that case, lambda 11 is 0.5. Lambda 12 is again 0.5. 0.5. 0.5 means M1 and M2 both has same effect on Y1. Similarly, M1, M2 has same effect on Y2. Therefore, M1, either M1 or M2 can be used to control Y1. The interaction is equal amount. Suppose I am having RGA like this, 0.6, 0.4, 0.4, 0.6 I got, let us assume. In that case, M1 has direct impact on Y1 and less effect by M2. That's why we have to use M1 to control Y1, but it has interaction. Similarly, for Y2, it has 0.6. That's why Y2 can be controlled by using M2. But anyhow, it has interaction, 0.4. The property of this RGA is, if you add row wise, you will get 1. If you add column wise, you will get 1. That's why there is no need to conduct 4 experiments to find all these 4 variables. If you know one variable, if it is 2 by 2, 2 input, 2 output means you can do. If you know this value 0.6 means without conducting experiments, you can write 0.4. If this is 0.6 means without conducting any experiment, you can write lambda 21 equal to 0.4, lambda 22 equal to 0.6. You can write without conducting experiment. These 3 elements you can find without conducting experiments if you know only one. So from this, we can understand that M1 should be used to control Y1. M2 should be used to control Y2. That we can understand. Suppose I am having a RGA like this. 2 I am getting greater than 1. Therefore, definitely this column must, this element must be -1. This is 2 means this is -1. This is -1 means this is 2. Then only if you add the rows wise and column wise, you will get 1. It means this M1 has strong effect on Y1. At the same time, M2 has reverse effect on Y1. That's why it is very difficult to control. If you get any negative values and greater than 1, it is very difficult to control. In that case, we have to do some other thing. For that, we can find decouplers. Decoupler means it will compensate for that interaction. This decoupler D1 will compensate for the interaction. What is the first equation we got? Y1 equal to M1 H11 plus H12 M2. This is the first equation. During interaction, I want to keep Y1 equal to 0. For that, I want additional M1. Find M1 here. M1 equal to what? M1 H11 equal to minus H12 M2, or M1 equal to minus H12 by H11 M2. So if we give additional M1 of this much, we can nullify the effect of interaction. Therefore, we can put D1 equal to the transfer function minus H12 by H11 D1. So what is the input for that transfer function? Here the transfer function is M1 of S by M2 of S equal to minus H12 by H11. That is the transfer function. What is the input? The input is M2, output is M1. So you will get additional M1 here. What is the input? M2 is the output. What is D1? D1 equal to minus H12 by H11. This is the decoupler. So this will give additional M1 to nullify the effect of interaction. In the same way, we can put another decoupler that will be added here. That is called D2. That will be added here. After this takeaway point, this will be added here. This will be added here. That is called D2. How to find D2? For that, we have to write this expression. Y2 equal to M1 H21 plus H22 M2. What is, we have to keep Y2 0. To keep Y2 0, how much additional M2 is required, I have to find. Therefore, M2 H22 equal to minus M1 H21. Therefore, M2 by M1 equal to M2 by M1. M2 of S by M1 of S equal to H21 by H21 by H22 minus. This is decoupler 2. D2 equal to what is the input? Input is M1. Output is M2. Additional M2. This is additional M2. This is M1 as the input. If you put this decoupler, you will get you won't get any interaction. This decoupler will nullify the effect of interaction. So this way we can design the decoupler. Here both decouplers are employed. The summing junction should be after this takeaway. Here also this summing junction must be after this takeaway. These two decouplers. If you find the transfer function by including decoupler, you will get the transfer function like this. For the 2x2 MIMO process, by including the decoupler, you will get like this. For this, if you find the transfer function for this first loop, what you will get? Y1 of S by Y1 set point of S, the closed loop transfer function.